want to bring your honors volume, which is volume 2. So the honors topic that says H47 is in the back of volume 2. Remember, I'll use that a couple times before we did complex numbers. So this is another one in the honors section. We're learning more about complex zeros and the fundamental theorem of algebra. Essential question. If a complex root a plus bi exists, what other roots must also exist? What am I talking about with the word root? Solutions, x-intercepts, zeros. Okay? Now, if it's an imaginary root, is that an x-intercept? No, it means it doesn't cross the x-axis. But some solution, then being a real root, that represents an x-intercept. Right? Okay? So, we're going to start with the fundamental, fundamental theorem of algebra. Okay, the fundamental theorem of algebra says a polynomial function of degree n, polynomial function of degree n has n complex zeros. These complex zeros can either be real or non-real. What does it mean if it's non-real? Imaginary, right? And some of these zeros may be repeated. Some of these zeros may be repeated. A polynomial function of degree n has n complex zeros. So we spent pretty much a whole term on quadratics. Quadratics are examples of polynomials. It's a bunch of terms being added or subtracted together with exponents. What's the degree of the quadratic? 2. So the highest exponent of the quadratic is a 2, right? What's the degree of a linear function? 1. So this says a polynomial function of degree n, so for instance the quadratic, that's degree 2, has 2 complex zeros. What are zeros? Solutions, roots, x-intercepts, as long as they're real. Right? So if I take a polynomial with degree 5, it can have, well, not can, it has, how many solutions? 5. If I give you a polynomial with degree 3, that means the highest degree is a 3, as a cubic function, it has how many solutions? 3. And these can be a combination of both real and non-real. So the real ones would be x-intercepts. The non-reals are still solutions, but they don't represent x-intercepts. Okay? So, that is the fundamental theorem of algebra. We want to use that to help us figure out if we found all the roots. Okay, for this example, we're going to write the polynomial in standard form. Oh, yellow. How did that happen? No one can see yellow. Right. The polynomial in standard form. There's another way to go. And identify the zeros and x-intercepts. And the zeros and x-intercepts. We're going to do 2 examples right next to each other. The polynomial in standard form and identify the zeros and x-intercepts. As not all the zeros are actually x-intercepts. Okay, this is this example. F of x equals x minus 2I times x plus 2I. First of all, in standard form. So we have 2 factors in parentheses being multiplied. How do we go from factors to standard form? Distribute. You guys distribute that? Okay, look at yourself, distribute. You have to watch out when I see i's in there. You can definitely button your answer with i's. I squared. Because I squared, now we know what's I squared's value. -1. So, I think everyone in here is capable of distributing that through. And then you need to make sure you change all I squares to the value -1. But, to write x. Yeah, use. And then my like parts, right? So just squish them together. And then write your answer in standard form, so it's decreasing in power, highest exponent first, down to lowest exponent. And distribute this. X times x, x times 2i. Good. So then it equals sign that I'm going with it. Around that for x. Okay, we turn down the equal sign, so it's still an equation. Make sure everyone still has f of x equals on the left, so it's still an equation. You can't change from equation to an expression. So we want equals f of x. And this to be as an equation also to the f of x equals that. Okay, remember f of x equals. F of x equals. Actually it's a plus. It's a plus because it's minus the y squared. And so that being minus because -2 times positive would be -4. Okay, so let's say Alex, what were the 4 terms you got when you multiplied each of those together? Okay, so she said plus 4, which comes from -4i squared, right? But I squared is -1, so it's really -4 times -1, which is positive 4. Look what happens in the middle. What happens to those 2 middle terms? Cancel. Can anyone tell me why? We can even expect that to cancel from the very beginning. Again, conjugate. Look at those 2 factors. X minus 2i, x plus 2i. They're exactly the same, except for one is minus and one is plus, right? Those are conjugates, so we can expect the middle values to real terms to cancel out. So that's with x squared plus 4. This is standard form. Okay, so we've done the first thing. Now we have to identify the zeros. How do we do that? We've done this by normal term. What type of function is this, John? What type of function? What type of polynomial? You know that. You know the name. True, it happens in binomial, but what type of equation is it? X squared equations have a name? Quadratic. Do we know how to find zeros on quadratics? How do we do it? Okay, we could do the quadratic formula. This one's a nicer one, though. Yeah? Don't be shy. That is Alex. Set equal to 0, because what are zeros? Don't they have to be equal to 0? Because we're looking for x-intercepts around the x-axis. Your height is 0, that's exactly right. Something says 0 equals x squared plus 4. We have 4 options to solve that thing. We just took a test on it. Quadratic formula, complete a square. This one's way nicer than using those two methods. We only use those two methods in the quadratic, it's not very nice. But we would take the square root here because how many terms do you have? 2. We're missing a linear term. So you can factor if you want, but your b is 0. A is 1, b is 0, c is 4. You can factor if you want, but this one's actually easier just to go minus 4, and solve units by itself, and then taking the square root. Okay. Oh my gosh, this was such a long break. Brando, what is the square root of negative 4? What do you have half the answer? Okay, now you have to give it half the answer. Let's go through that. Plus and minus. Because the square root is negative, isn't that an imaginary number? Yeah, square root of the negative is an imaginary number. And the square root of negative 1 is I. Square root of 4 is plus or minus 2. Red. Negative is I. Now, we can't say positive 2i. Here's a hint. Conjugate, complex solutions always come in pairs. They always have a conjugate. You can guess later. The book will only give you one of them, and you should automatically know another one exists. From the fundamental theorem of algebra, we have a quadratic function. How many total solutions are there supposed to be? 2. Because of x squared, which is 2. So if you only put plus 2i, you're missing one of them. So we have conjugates, positive 2i and negative 2i. Complex roots come in pairs. Okay? And let's see, one more question. We're going to do what about x-intercepts? Out of these two answers, which ones are x-intercepts? Positive 2i or negative 2i? They are. Oh, Alex is on fire today. So we should be better about that more often. What is it? Neither. Why is it neither? They're imaginary. You have to be real to be x-intercept. So these are zeros, but your x-intercepts. I'm sorry. And none. We have no x-intercepts, but they're not real. You should know what this graph looks like. And then x equals x squared plus 4. The 4 is in the K position. Raise your hand if you can tell me what the 4 does to the graph in 4 words. Raise your hand if you can tell me, because the 4 is in the K position, what the 4 does to the graph in 4 words. Okay, I have a couple of hands. I need some more hands. We just click an assignment where number 1 and number 7 have the exact same answer. No one in that row knows? Shakira? How many? 4. And I can graph this without even looking at a these roots or zeros are not actually x-intercepts. So there are no x-intercepts. Okay, let's try that one. Okay, f(x) equals x minus 3 times x minus 3 times x minus I times x plus I. Okay, I want you to look at how many x's are there. And I want you to work up in there what's the degree of this polynomial. If you want to multiply everything out, what's the degree of the polynomial? Yeah. What's the degree of the polynomial? How many x's are there going to be multiplied to each other? So it would be x to the fourth. So it's the fourth degree. So by the fundamental theorem of algebra, how many solutions should there have to be? 4. They can be a combination of real and imaginary, or they can be all real, or they can be all imaginary. So we have up to 4 x-intercepts with this graph too. So let's find standard form. Remember how we had a test a while back that had multiple binomials being multiplied? Should we multiply all of them at the same time? 2 at a time. I would take 2 that look nice first. Which 2 would you do first? Yeah. Okay, so on your paper, multiply those 2 together first. And simplify them. So yeah. Good. And then I put it in brackets and take out your equals f of x. We're going to look at all those eventually, but we can't really do all 4 at the same time. We can multiply in any order we want because of the commutative property. So we're just going to take the 2 that look nice together first. And then we'll multiply the others in a minute. Okay, after you multiply them, you either find your like terms and then I put everything in a bracket. That's it. I don't know what you do here. One of these is supposed to be, well, those are both negatives. So we don't cancel out. Okay, we multiply those together. I think it's, don't divide, don't do that. Because that number's only 3, so we can't do that. Just want to combine those 2 terms in the middle. Okay, guys, can you tell me what you got when you multiplied x minus 3 times x minus 3? Wait, sorry, come on, listen. Oh no. Did you get 4 terms when you first multiplied them all together? What? What were the 4 terms you got when you multiplied them all together? You didn't get 4 terms? Okay. Let's go. What is x times x? Okay. Then x times negative 3. Negative 3x. And then we have to take the negative 3 and we'll distribute it in as well. So negative 3 times x. And then negative 3 times negative 3. Yep, positive 9. Yeah. So we have like terms here in the middle. Look at the only 2 that are like terms. They don't cancel out because we're these 2 conjugates. No, they have the same subtraction sign in the middle. So I'm going to have x squared minus 6x plus 9. Now, I have to do the brackets around that because all that stuff is being times still to x minus 1 and x minus I and x plus I. Look at these 2. You can tell me in that vocabulary about their relationship. So that's, we can tell us this relationship, true? Let's go down. Con, Jew, on the conjugate. That is a big word, conjugate. Because they're exactly the same, the one's plus, the one's minus. So, before I use this trinomial we just got, this guy, I'm going to now multiply these together, and since it's the conjugate, I should expect what to happen in the middle. I should expect the middle terms to cancel out. If they don't, I've done something wrong. Okay, so we're going to go through and multiply x minus I times x plus I, and combine my terms, and make sure all I squareds change to negative ones. That's, yeah, it's like a bridge, also too, in between, I think one, but yeah, put subtract it here, yeah, that works not on. That's just where the first term square, also two, in between the first and last, put subtract your two. The first one also has on because x minus 3 is, x minus 3 is just a perfect square binomial. So that was first square, the first term square, awesome 2. In between the first and last is first term, so awesome 2. Yeah. Take and show some. Do x times x and then x times I. Yep, okay. So don't put equal sign there. I think this is right. We just need to put brackets around because it's being times to this bracket. Okay. True. Let's get out and multiply them all. The string of 4 terms. Oh, because originally it's minus I squared, right? And minus I squared is actually minusing a negative 1, which is just plus 1. So we end up having x squared plus 1 because the middle terms, do they cancel? Yeah. Okay, we're almost done. What's the last thing we need to do? Yes, me? Let's try to get these two. Now careful here. We have a trinomial times a binomial. So 3 times 2, how many terms should we get? 6. So make sure you get all 6. And then you need to watch out for like terms and I squareds. I'm going to spend much time back here. Ready to get it all? Oh, yeah. I was going to get my book out. Okay, and that's going to be good job. We have the final answer in standard form with all of those combined and simplified. Good. Good. There's an equals up and x in front. I think that's equals. But other than equals f of x. Good. Let me just move the f of x in front of the equal sign. And we'll go right terms in there. Yeah. F of x equals in front. disconnect. Yeah, that's got no find this. X squared times X squared. Okay. What happened there? You're missing a 10. You're missing a cubic. I don't know. Check it with calculus. See if you can find it there. Okay. V equals f of x. Now, it gives me an equation. Okay, if you multiply this out, you should have got x to the 4 plus x squared minus 6x cubed minus 6x plus 9x squared plus 9. And then what are our like terms? The x squareds. We're the only set that were like terms. So standard form has to be ordered. X to the 4th minus 6x cubed. Then the squares, there are 10 of them. Minus 6x plus 9, and then what did I fix that? The offset can do as well. And then x, so then I leave it aside. They can't all of a sudden become an expression. So that's standard form. Now, there's two more things you need to answer. It asks what are the zeros and the x-intercepts. Well, zeros come from applying the zero property, which is applied on factors. At the very beginning, didn't we have factors? Yeah, we have factors. So we can just take all of the factors and set equal to 0, which essentially if x minus 3 equals 0, what's x going to be? Positive 3. X minus 3 equals 0, what is x going to be? Positive 3. If x minus I equals 0, what's x? I. Because I minus I is 0. If x plus I equals 0, what is I going to be? Negative I. So we have to determine which ones are x-intercepts. The first two, but notice it's the same number. So we call this our zeros. This is how I would answer. Our zeros are we have 3 with a multiplicity of 2, and it's repeated twice, with a multiplicity of 2. I know writing 3 on the 3 is faster, but you need to know what the multiplicity means. So you need to write a multiplicity of 2. It means there's 2 of the same value that are solutions. And we have plus and minus I. Out of those, our x-intercepts is only at x equals 3, right? Because only the real one can be an x-intercept, the imaginaries are solutions, but they're not x-intercepts. Okay, clearly a question. Yeah. Okay, let's look at something new. Now, if you pay attention to something I said earlier, you should be able to catch something. What's missing? Example 3. Write a polynomial function with minimum degree. Right? A polynomial function with minimum degree in standard form. With real coefficients, whose zeros include -3, So basically we're working the problem backwards. It tells us the solutions. We have to go up the ladder and write the polynomial in standard form. Okay? So based off of the zeros they give us, can you figure clear what is the degree of this function? The reason it says minimum degree is because it doesn't tell us if there's repeats. So if there's repeats, the degree would be higher. So what's the minimum degree this function could be? Put it up next to high in the air. Go back to the other one. Okay, so far is John and Allison and Abby and Josh here are right. Which is why, you know why? It's not 3. The correct answer is 4. The correct answer is 3 zeros. The correct answer is 4. Can you tell me why? It has something to do with the I. But I say about the conjugate, or I can say conjugates, the complex zeros. Complex zeros have to come in pairs. They only give you one. But since they give you one, you know another one exists. The conjugate also exists. Okay, so write them down if you all forgot it. Complex zeros always come in pairs. Conjugate pairs. You know, I'm going to put that word in there. Conjugate pairs. I'm going to put stars around it so you guys can find it again. Now we've got the smiley face one with the rainbow on. You're like, rainbow power, no. Okay, so if our conjugate, if our given 0 is 2 minus I, what's its conjugate? 2 plus I. I'll go back to my regular pen. So there is a fourth one we can add in, 2 plus I. Now we have to write standard form. So I'm going to go back to the beginning, because we're reversing the order we're used to doing things in. Okay, look at example 2. One of our answers was 3. The solution where the 0 was 3. What does the factor look like? X minus 3. One of our solutions was I. What does the factor look like? X minus I. One of our solutions was negative I. So the factor was X plus I. So think about that. If our solution is negative 3, check your neighbor, tell them what the factor should look like. Check your neighbor, the solution is negative 3, check your neighbor and know what the factor should look like. Alright, now let's do it again. X plus 3. So everyone put that in parentheses, so everybody don't yield. Okay, back. Our solution here is 4. So what would the factor look like? Good. X minus 4. Now, the complex ones are a little funny looking. We put a bracket. We start with X, but since it's positive, we're going to subtract parentheses 2 minus I. We're subtracting the whole thing. Same with the other one. It's also positive, so the other one's factor would be X minus parentheses 2 plus I. Okay, so writing the factors of the complex zeros is a little tricky. So you have to make sure you minus the whole thing. So put the whole thing in parentheses. Can anyone off the top of your head tell me of those multiplied together? That's the long version. Minus x. That was one fire today. Because it's negative 4x plus 3x is minus x. And 3 times negative 4 is minus 12. I won't write that down. We already know how to distribute, so we're just going to jump ahead. On the other side, it takes a little more work. Before I can distribute, first I have to take care of the minus. Okay, Perla, can you tell me what my new brackets that will be when I distribute in the minus? Starting with the x. That's not a great part. Any of those like terms? No. Let's do the other one. First, I'm going to take care of the minus. There we go. What would this one be? My new bracket, when I simplify, distribute in the minus. And then minus e, a positive I. Minus I. Or get these like terms. No. Okay. What do I have to do to get our standard form? Distribute. Do you want to distribute these two together first? You want to do these? You know why? Conjugates. What's going to happen in the middle? Cancels. If you have conjugates, put those together. Okay, multiply those two together. Change all i's to I squares. And then combine your like terms. Let's see if I can. Okay, after you have simplified the two trinomials with i's, raise your hand, I'll come check to make sure you do it right. In terms of x times x, that x needs to go in 3 times. The negative 2 needs to go in 3 times. The I needs to go in 3 times. Yeah, because 3 terms times 3 terms, how many terms should we get? 9 terms. So be very careful with your screenshot 9 terms. That's how you know you should be on the right track. And then you're going to have some like terms that they need to combine. After you've done your string of 9 terms and combined it like terms, raise your hand, I'll come verify that you did that right. Okay, so that's a string of 9. And then we need to find the right terms inside. You can change that to positive 1, so that's good. Yep, so there's right terms in there, and some of them ready to cancel out. Okay. Don't be right here, right? We do x times x. Multiply x in 3 times. These two, we're just ignoring them for the time being. Okay, let's do in your string. Emily, can you tell me the first 3 terms? Okay. IX. Or XI. Okay. Alright, moving on to the next string, we take the negative 2 and multiply it in. Okay, well, Good. And then we have 3 more, which is when we multiply the I inside. Okay? So, just get all the way over line. I'm going to do the I times the table.
So it's xi minus 2i minus I squared.
Cool, minus I squared, good. Are there like terms? Yeah, so I would go through and start with the x squared. Any more x squareds? No. Then I give a new picture to the negative 2x with no i's. Tell me to stop when I get another term. There's an x to the first power and no i's. So how many are those together? Okay, now I have an ix. Tell me to stop when I get ix. Oh, they cancel. Ouch. Everything with an I cancels out if you finish it. Now I have a constant 4. Is that another constant? Yes, it is. This guy is actually what number? It's a negative 1, which is a positive 1. So it's plus 5. And then 2i cancels with negative 2i. So our last thing is multiply those together, and I'm just going to tell you what it comes out to be, unless you've already done it. It comes out to be the following: x to the 4th minus 5x cubed minus 3x squared plus 43x minus 60 equals, which has in the front. This is just the answer if you were to go through and distribute all those. That's what you get. Did we in fact get a power of 4? Because we predicted there would be 4 solutions. Yeah. Okay. I'm going to do the last problem differently with you guys because I started along with a really hard problem and it was really torturous. So the last one, you have a worksheet for it, which we're going to be studying about. We're going to keep on with this next time as well. I couldn't remember that. I really don't know. Here it is. Okay, the very last problem, we're just going to start laying out all my problems on synthetic division so you know how to do it. So next time we're going to come back and do a synthetic division on one that has complex zeros. So this worksheet has synthetic division. Probably, we've been on for a long time too. So you probably need to zip it and catch up. Okay. If we're all quiet, we can probably zip through a couple of these really fast. And then next time we'll work more on synthetic division and solving when these roots are complex, it'll be easier. So let's start your first one together. Number 1 says, use synthetic division to divide this by a linear factor. Which one's linear? This one linear? Is this one linear? This one's linear. Is this a solution? No, it's a linear factor. So here's the setup for synthetic division. The solution goes here, and then you write down all of the numbers in order. I'll do that in a minute. So the basic idea is you always add the columns and you multiply the diagonals. So, no, it's way easy, guys. Once you go on, you'll see it's way easy. X plus 2 is a factor. What's the solution? No, you said equal to 0. -2. x plus 2 equals 0, negative 2 would make that equal 0. So I take negative 2 and put it in my little divisor box. Then I'm going to take all of the coefficients from my polynomial. You have to be careful though, because the one we're going to do next time is missing one of them. Make sure you have all of them accounted for. X squared, x to the first, x to the 0. Do you have any holes? No, this one has no holes. So I take the coefficients 3, 7, and leave a little bit of space, and 2. The next couple lines, I'm just going to put a little addition bar. We add the column. So starting with 3 plus nothing below it, like that. 3. So we add the columns, take whatever number I get, and I multiply it to the box, and I put it right here. So 3 times I divide it in the box, that's 3 times negative 2. Negative 6. Then I add the column. 7 minus 6 is 1. I take that 1 and multiply it. Negative 2. Okay, so anything down here, underneath the line, you multiply to a box. 3 times negative 2 is negative 6. So then I put it in my next column. And then I add 7 minus 6 is 1. And 1 times negative 2 is negative 2. Now I add 2 minus 2 is 0. We know it is definitely doesn't say, oh, it doesn't say verify, but it is a solution if you get a 0. Okay? It's a solution if you get a 0. I'm going to try to note this down. So, here's how the answer comes out. Remaining 0. Maybe I'll just put remaining 0, so 0 is bigger. I work backwards. My first term is my constant, and it's a positive. My next term is my linear, 3x. If I have another term, that would be my x squared. If I have another term, that would be my x cubed. So this is what remains after you divide by the first solution. And now if we step down and went from a quadratic, we divide it away one of the x's, and now it's a linear. Oh, should we try it on? The R means remains at 0. Remember long division? Shh, let's do another one. If you have quiet, I can do 5. If you're talking all the time, we're not going to have time for 5. Okay. This is a factor. It is not the solution. What's the solution? Negative 2, not positive 2. Now I have to be careful. I can see number 5 is not in the right order. It's all mixed up. We have an x to the 4th, we have an x cubed, we have an x squared, we have an x to the first, and we have an x to the 0. So everything's there, it's just not in the right order. We need to make sure to write down in order. So x to the 4th, that coefficient is negative 1. X cubed, what's that coefficient? Negative 2. Then I do my x squared, what's that coefficient? 3. Then I do my x to the first, which is 4. And then I do minus 4. And I always try to leave some space between them, so there's plenty of room and I don't get confused what numbers where. So we add columns. Negative 1 plus nothing. Negative 1. I take this number and multiply it in the box. Negative 1 times negative 2 is positive 2, so I put it up there. And I add it. I get 0. 0 times the box is 0. I add it, but I'm not adding since I'm saying 0. I add it. 3. 3 times the box, negative 6. positive 4. I have them. 0, is that what I want? Is the 0 at the end? Yes, it means it's actually a true solution. So I write my answer. Remainder 0, and start on the right-hand side, which we're not usually used to. The first one's your constant. 3 is our exponent first, and it's positive, so it's plus 3x. Then we have a plus 0x squared. Do I really need to write that? No, but just click on myself, I'm going to put it there. My x cubed has what in front of it? Negative 1. And this was, yeah, we don't have the equation, so we don't have to put after x equals. Okay. So, I want you guys to switch the homework that you guys have, and it's going to be trains anyway. So you and first grade are doing different assignments, but next time you do an assignment they're doing, and they'll do an assignment you're doing. So your homework is finish this worksheet, okay? And we'll ask a question on next time. I started them off really hard, synthetic divisional complex. That is first. It was a little painful, so why you guys decided that we would do the easy one first. Easy into it, and next time we do the hard one.